Welcome to section 6.2 on the determinants of small matrices. The goal of this section is to introduce the notation of determinants and to define the determinant of 1 by 1, 2 by 2, and 3 by 3 matrices. Definition 6.2.1. If A is a 1 by 1 matrix, which is a matrix with one row and one column, and therefore a single entry, if A is 1 by 1, then the determinant of A is, here's the notation, det A. It is, well, it's the entry of A. It is the single number that is the single entry of the matrix. 2. If A is a 2 by 2 matrix, A, B, C, D, then the determinant of A is, here's the notation again, det A, and a new notation, vertical bars. The vertical bars around the matrix entries instead of the square brackets, right? So vertical bars, no little edge to them. Those vertical bars also mean determinant, and for this 2 by 2 matrix A, it is the number that we've seen before, AD minus BC. Now it's nice to think about this as sort of a cross product like motion. So we have a down product A times D minus the up product B times C. And that is really nice because that down and up product motion continues in number 3. If A is now a 3 by 3 matrix, A, B, C, D, E, F, G, H, I, then the determinant of A is, here are those two notations, det A and vertical bars around A, B, C, D, E, F, G, H, I. Then the determinant is, well, the calculation is actually, it's something that nobody remembers the formula of. They remember the method. And the method, like you did with the cross product, involves recopying. It involves recopying the first two columns outside of the determinant bar. So I've taken the first two columns here, ADG, recopied it, BEH, recopied it. And now what I'm going to do is something very similar to number 2. We're going to take down products, but there's going to be 3 diagonal down products. And we're also going to have up products, but there's again going to be 3 diagonal up products. And so now we take the sum of those diagonal down products. So I have AEI plus BFG plus CDH. And that term is then subtracted, or we subtract from that term the sum of the up products. So GEC plus HFA plus IDB, the sum of those up products. So we're doing down, 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 minus up, up, up. Right, so a very similar motion to here, except the down products have 3 terms and the up products also have 3 terms subtracted in between. Comments about the notation. So the 2 most common notations are shown above, the det and the vertical bars. Although we don't use the vertical bars for the 1 by 1 case, because if we put vertical bars around a single number, it looks like the absolute value bars, and that's not what we want to have. We don't want to create confusion with the absolute value. Other variations on this notation include, well, sometimes people put brackets, so they'll put det of bracket A, parentheses A. Sometimes they'll put the whole matrices in the whole matrix in the bracket, so det of A, B, C, D if we have a 2 by 2. And sometimes they'll use the vertical bars around the name of the matrix. Those are also common notations. Remark, this method here in number 3 of recopying the first 2 columns and doing the diagonal products to calculate the 3 by 3 is often called Sarrus's rule. That's actually how it's pronounced in English. It's a French name, Sarrus, but it is Sarrus's rule in English. That's very, very often the name of that, or how that method is referred to. And in section 6.4, we're going to see the determinant for larger matrices, right? We've only got a 1 by 1, a 2 by 2, and a 3 by 3 here. We know that larger matrices exist, and so we're going to see in a later section a method called cofactor expansion that will allow us to calculate the determinants of larger matrices, and at that point we will also check that the definitions given here for the 2 by 2 and the 3 by 3 are going to be consistent with that more general definition.